Hello, welcome to College Algebra, section 5.6. This is Rob Reynolds, and today we're going to be looking at continuing our discussion on finding equations of polynomials, rational functions, and today we're going to be looking at irrational roots in the form of a plus bi. So whenever they ask for a complex number, we're looking for something like 5 minus 3i, usually coming from the quadratic formula. And if 5 minus 3i is a root, we're going to learn today that 5 plus 3i also is a root. So here are some notes. Complex number, first and foremost, just comes in the form a plus bi. So that's what I'm going to be referring to as a complex number. Some more notes. Every polynomial can be factored. It just may not look nice. And if 3 minus 4i, we just change the middle sign and we get 3 plus 4i. Has to be a factor, because it comes from the quadratic formula. X is equal to negative b plus or minus the square root of that negative number, which causes that all divided by 2a. So that's what's forming this. So a conjugate, by definition, literally just means change the middle sign. So whenever I say take the conjugate, we're just going to look for the middle sign and change the middle sign. So pluses go to minuses, and minuses go to pluses. So again, if you have a plus bi and it's a root, it's an imaginary number, then a minus bi has got to be a root as well. So here it comes. This is not pretty, but there's a degree 5, and it says, oh, no, this one's not bad. This one just says list the other zeros. So if negative 2, we'll just leave that alone. Positive 2 is not necessarily a root. In fact, I'm going to say that it's not a root, because this is 1. There are 2 from here. So if negative 3i, there's a positive 3i, and if 2 plus 4i is a root, then 2 minus 4i is also a root. And I've got all 5 of them. 1, 2, 3, 4, 5. I got all 5 roots, so we don't want to mess with the negative 2. If they were asking me to write the equation of the polynomial, I'll have to write all of those in factored forms. So they say write a degree 4. Looks like if 1 is a factor, then x minus 1 is, if 1 is a root, x minus 1 is a factor. X minus 1 is a factor again. This is actually x minus 4 plus I. And if I distribute that, it's x minus 4 minus I. And then if I know that 4 plus I is a root, then 4 minus I is also a root, which if I distribute the negative becomes negative 4 plus I. So I'm not going to write this stuff out again. It's just x minus the root. So x minus 4 plus I is here, and x minus 4 minus I. Most students get this pretty well. Hey, remember from past chapters that I times I is negative 1. So I would recommend that you FOIL imaginary numbers together because they will turn real. So this gets a little bit long. In lots of places it's a little bit tedious. A lot of places make mistakes. But let's continue distributing the x throughout. So negative 4x plus xi. It's kind of weird to have an xi term, but we'll live with it for a little bit. Take the negative 4 and distribute that to all 3 terms. So negative 4 times x, negative 4x, negative 4 times negative 4. I don't have a 16 or a real number, so I'll just create something new. And then negative 4 times I don't have a I term. I have an xi, but I can't add xi and 4i, so I'll just create another row for that. Let's do the multiple, distribute the negative I times. Hey, this is nice. Negative xi is going to cancel. This will cancel because negative times negative is positive 4i. And then here I'm going to write this as negative I squared, but I want you to recognize that that's the opposite of negative 1, which is really a positive 1. So when I add this up, this term, this positive 16 and this positive 1, will actually give me a whopping 17. All of this will cancel, and I'm left with x squared minus 4x plus 17, but you're not done. You got to FOIL this up too, which gives you x squared minus 2x plus 1, and I need to continue to multiply, stack, and add. So let's keep going. Distributing negative 4x cubed and x squared times 17. Ugh. And let's go distribute the negative 2 times x squared is negative 2x cubed, so I'm going to stack that on top of my x cubed terms. This is positive 8x squared. Lots of places make a mistake. I hope I'm doing okay. 17 times 2 is 34. And let's go back and grab The one, oh good, the one would be easy. Just transfer this along. So, extending the page some more, hope you have plenty of room to do these problems. Combining like terms, what is this? 26. 38, I feel like I made a mistake somewhere, but hopefully that's correct. You get the gist. Hey, ooh, they have a value of A up front. Let's see, 26 and 17. Is that what I meant? Holy cow. Let's see. Yeah, I have a negative 38x. How did that happen? It's not what they had, is it? Well, I made a mistake somewhere. Darn. You can see it. So, I can't add very well. Looks like negative 4x and negative 4x is not negative 4. This should have been a negative 8. Oh my gosh, which really messes up things in here. But here it's worked out correctly. There's that negative 8 term, so forgive my math. I would like for you to know that it's any multiple, because this is your vertical stretch, so there's an A term. So I apologize, there's an error in there somewhere, but I'm not going to go back and rework it. I think you get the gist. All right, so every polynomial can be factored. Okay, so now we're going to be looking at if I don't give you any of the roots, which I will on the test, then you're going to have to do Descartes' rules of signs and look for your P divided by Q, the rational root theorem, and start synthetically dividing and looking for 0. So we can test a 1 here really quick and just see how I can tell the 1 is not going to give me a 0 because, well, I haven't done it, but I can see that all of these are going to be positive numbers here. So this is positive, this is a bigger positive, this is a really big positive, and it's just not going to give me a 0. So I know that 1's not even a root. So I don't have to sit here and try. I'll try a 1, I'll try a negative 1. No, none of those work. And the book expects you to sit here and try synthetic division. I would use my calculator and do guess left, guess right, guess on. Finally, you find one of the roots, negative 2 gave me a 0, and then you have to continue this process and keep factoring. Maybe you could factor by grouping like this author did to come up with the rest of the factors. So again, what I'll be asking you to do on your test is determine the degree. So the degree would be the maximum number of roots. In this case, it's 4. Use Descartes' rules of signs like what I taught you in section 5.5. For the positives, I just count the flute-de-dupes, how many sign changes there are. There's only 1. So there's only 1 possible positives. And then for the negatives, I would list f of negative x. And every time I see an x, I'm thinking this is negative x, so that's a positive. If I throw in a negative x there, that'll change that to negative. This will remain positive, this will go to positive, and this remains negative. So counting the sign changes, there's 1, there's another sign change, and so it could be 3 or 1. So that's kind of helpful because now I know that not all 4 roots are negative. There's at least 1 positive root. So I could try Descartes' rules of signs, I'm done with Descartes' rules of signs. I could try the rational root theorem, P divided by Q, the last, divided by the first. Oh, that's just all the factors of 20. 1 and 20, 2 and 10, 4 and 5. And remember, it's plus or minus all of those. So those are the possible places that the function could cross. It doesn't mean that those are answers, but those are, in other words, don't try to synthetically divide by a 3. A 3 will not give me a root 0. It's not even possible. That's what the rational root theorem says. So this one was reviewing just how to, if I give you 1 plus I, we want to write it as 1x minus the root, and then x minus the conjugate of the root, and you have to multiply, stack, and add to find the real, and then you multiply by this term again, and multiply, stack, and add to find another real. So I wanted to show you one last concept here. I don't think I've shown you, if I give you an imaginary root, how to synthetically divide by imaginary roots. Now, you can synthetically divide by fractions as well, which is complicated, but imaginary roots are a little bit even more complicated. And if, by the way, 3 minus 2i is a root, then we know that we need to synthetically divide by 3 plus 2i as well. So remember, I should end up with a 0 after I get done synthetically dividing, and this is no easy task. Plenty of places to make mistakes. So watch me and yell at me if I make a mistake. Bring down the first term, multiply 3 minus 2i, so adding Negative 6 minus 2i, remember you cannot combine. I had one student try to combine those, don't. Not like terms. Let's multiply. Let's see. 3 minus 2i. I'm going to do some scratch work over here. I'd recommend that you do the same thing. My first terms is negative 18. The outer is negative 6i. The inner is positive 12i for a total of plus 6i. And the last is negative times negative, which is positive 4i squared, which we know as 4 times negative 1, or negative 4, combining with the negative 18, is negative 22 plus 6i. I think that's right. We'll find out at the end if I don't get a 0. So negative 1 plus 6i is where I'm at. Let's multiply again. This time, it's going to be 3 minus 2i times the negative 1 plus 6i. Alright, so here we go again. 3 times negative 1, negative 3. The outer is 18i. The inner is plus 2i for a total of 20i. And the last is minus 12i squared, which we know is plus 12. I'll combine that with the negative 3 for a total of 9 plus 20i. Now I'm going to add the 21 and 9. Gives me 30 plus 20i, and I'm going to do this one more time. I'm running out of room, so I'm going to do this over here this time. This is 3 minus 2i times the 30 plus 20i. Oh, I hope this gives me right. So 90, the outer is negative 60, the inner is supposed to be positive 60, and negative 60i, those cancel, that's conversion. Minus 40i squared, which you know as plus 40, and boom, there's 130, and I got my 0. Very happy. Now, I need to repeat this process, but this time I'm going to synthetically divide by the conjugate, which is 3 plus 2i. So bringing down the first term, I'll try to write small here, 3 plus 2i, the i's cancel, giving me negative 3 times this again gives me negative 9 plus minus 6i, which gives me negative 10. Let's multiply negative 10 times 3. Yay, that looks good. Negative 30 minus 20i. Good, I got another 0. I knew it should be a 0 because they're telling me it's a root. So now I'm left with just the simple task of factoring what's left. Remember, this is my x term, this is my squared term, this is my x term, and this is just my coefficient. So I knew that was true because it started at x to the 4th and it dropped to x cubed. So factoring factors of 10 that differ by 3 are 5 and 2. Signs are different. The larger term is negative. And my last two factors are 5 and negative 2. That is very difficult. I'd like to show you what it looks like on the test. I think it's a little bit easier. Remember, if negative 4i is a root and gives me a 0, then I have to synthetically divide by 4i as well. So I think on the day of the test, it's a little bit easier to synthetically divide. We'll multiply here. Negative times negative is positive 4i, so 4i plus 2. Multiply again. This is going to be negative 16 I squared, which is positive 16, minus 8i. And the last one, yes, if I add this up, gives me, because negative 17 is positive 32, but it's I squared, so negative 32. So that did work. So let's synthetically divide by a 4i. Bring down the first term, multiply. The I terms drop out. Left with 2, and sure enough, this is 8i, which gives me 0. So remember, this was an x cubed term, this is an x squared term, so this is just an x. Negative x plus 2 equals 0, which means negative x equals negative 2, which means x equals 2. And there's only 3 roots, because the highest exponent is 3. So I found 2 imaginaries and 1 real root. So I'm going to post a review on Blackboard, so if you have questions about working out any of these problems, this is question number 6 off of one of the reviews. I think I have a couple of reviews. If you have questions, email me and I'll try to answer your questions. Thank you.